Hi everyone, this is Amy from the Helms Academy, and today we're doing a Math Roundtable recap from our July 16th session. So today we'll start with our steps to solving a word problem. So if you see a word problem, the first thing you want to do is identify the important information. And I'd recommend that if you can write on what you're working with, to circle it or highlight it or underline it so that you can always go back easily to that information. The second thing we're going to do is determine what operations that we need to use, and then we're going to write out that problem using the numbers and operations. So we'll take it out of our initial words and bring it into numbers and math concepts. And from there, we'll be able to solve. Our first problem today says this: Rita caught fish that weighed 3 1/4 pounds, 8 1/2 pounds, and 4 2/3 pounds. What was the total weight of all the fish that Rita caught? So when I look through this, I see the numbers 3 1/4, 8 1/2, and 4 2/3. And anytime you see a number or a number word like twice or triple, I encourage you to circle that. And then what are we looking for in this problem? Well, we're looking for the total weight. So there are a few different ways to solve this problem, but here's one that I really like to use. When I'm adding together to get a total, I want to take all my numbers and put them in one equation. But when I'm working with mixed numbers, sometimes it's easier to separate out my whole numbers from my fractions and add them together at the end. So that's what I'm going to do today. I'm going to take my whole numbers first, 3, 8, and 4, and add them together. So right away, I get the number 15. Now, if I go over and look at my multiple choice options, I will see that there's one of them that's below 15. And I already know that's not going to be an option because this is just the beginning of my addition. I still have more to add to this. So option B, 14 2/3, not going to be an option for me. And I can even get rid of option D because I know there's still more being added to this and my final answer can't just be 15 pounds. So that leaves me with just letter A or letter C. And right away, just by doing a quick bit of math here, I can give myself way better chances of getting the right answer. Let's look at our next step. So next we're going to look at the fractions. So the fractions are 1/4, 1/2, and 2/3. And I want to add those together, but the problem is right now they don't have a common denominator. So I need to look at 4, 2, and 3 and figure out what the common denominator between those three are. Well, the lowest common denominator is 12. So what I'll do is I'll transform all of those fractions from their original form into something that has the common denominator of 12. And the way that I do that is by multiplying the numerator and the denominator. So for example, for 1/4, I know that I need to get that 4 to be a 12. So I'm going to multiply it by 3. Now, if I multiply that denominator 4 by 3 to get 12, then I also have to multiply my numerator 1 by 3. So 1 times 3 is 3, and 4 times 3 is 12. Now, 1/4 and 3/12 are actually the same amount. And how I want you to think about that is if you had a pizza and you just cut it into 4 really big slices and ate one of them, that would be 1/4, right? Now, let's say that you took each of those slices and cut them smaller, right? And you cut them into 12 parts, but you ate 3 slices instead of just 1. Well, that would be the same amount of the pizza, all in all, right? You'd still have that one section gone. So 1/4 and 3/12 are the same value, just written in 2 different ways. So we're going to do the same thing with the 1/2 and the 2/3. And the 1/2 would become 6/12 because we're multiplying that 2 by 6 and that 1 by 6. And 2/3, well, there's the denominator 3, which we're going to have to multiply by 4. And so we'll also do that to the numerator to get 8/12. Now, I love adding fractions because once you get that common denominator, you just have to add the numerators together. So we're going to do 3 plus 6 plus 8 is 17, and we keep our denominator, so we get 17/12. Now, you might have a little light bulb going off that says, that's not a good fraction, right? That's an improper fraction because the numerator is bigger than the denominator. That's okay, we can work with that. We'll just turn it back into a mixed number. So here we have 17 12. So we need to ask ourselves, how many times does 12 go into 17? Think about it like a division problem, right? 17 divided by 12. Well, I know that 12 goes in one whole time. And then what's left over? Well, just 5 is left over. So we'll do 1 and 5 twelfths. So if we put all of that together, we take our whole numbers, which added up to 15, and our fractions, which added up to 1 and 5 twelfths. We'll get 16 and 5 twelfths. Word problem 2 says, Laura paid $17 for a pair of jeans. The ticketed price was 20% off the original price, plus the sign on the rack said, take an additional 15% off the ticketed price. What was the original price of the jeans? So here I'm looking at the numbers to stand out first. So I have $17, I have 20% off original price, and I have 15% off the ticketed price. And what they want to know is what was the original price of the jeans. So if we bought the jeans for $17 and we got a deal on them, we know that our original price is going to be higher. Now, what I've done is I've put this together in an equation. I said, here's what I know. I know that to get to $17, which is the answer that I have right now, that we had to take that original cost, the original price, which I put down as C here, C for cost, and then I had to pay some portion of that. So I saw, okay, it was 20% off or 20% less than the original price. So I said, well, why don't I do the reverse then? And I'll multiply this by the amount that she did pay, which was 80% of that cost, right? She had 20% off, which means that she ended up paying just 80% of the original cost, not quite the whole cost. So if I had the original cost times 80%, that would give me the ticket price. However, I also get to take an additional 15% off that price. That's why I have the C times 80% in parentheses, because now we're going to get another discount, but that discount is only based on the price that's in parentheses. So what I'm going to do is multiply that price by 85%, because I had 15% off, which means that I only paid 85% of the cost there. So by setting up this equation, I now have something that I can solve for and see if it works for one of the answers that's provided here. So the first thing I'm going to do is change my percentages to decimals. That'll make them a little bit easier to work with. And changing a percent to a decimal is really easy. I'm just going to go and take it 2 decimal points over. So if I think about it like 80 with a decimal point after the 80, I'm going to go over to the left 2 places, so it becomes 0.8. Same thing with 85. I'm going to go over to the left 2 places, so it becomes 0.85. All right, so now I have 17 equals C times 8 times 0.85. Now, if I want to get that C by itself, what I'm going to have to do is get rid of the other things around it. So I'm going to start with the things that are isolated, and we have that times 0.85. Now, to get rid of something, I just have to do the opposite. So the opposite of times or multiplication is division. So if I divide by 0.85 on both sides, 17 divided by 0.85 is 20, and it cancels out on the other side. So I get C times 0.8. Now, if I want to get rid of that 0.8, I need to do the same thing, and I can get C to be by itself. So again, if I had times 0.8, now I need to divide by 0.8 on both sides. And 20 divided by 0.8 is 25. And that is the total cost, or the original price, of the jeans. Now, we talked on our call today about how another option here would be to work backwards. If you're feeling stuck and having difficulty putting together an equation, you might start with the answers at the bottom and take each answer and say, okay, what's 20% off of 30? And then of that cost, what's 15% off from there? And you should get 17 for the right answer. And that's another way to solve this problem. For word problem 3, it says several students are going to ride their bikes from the city park to Lake Kegonsa, a distance of 25 miles. They will ride at an average rate of 10 miles per hour. What is the latest time they can leave the park in order to arrive at the lake by 11 a.m.? So I'm going to identify here that I need that 25 miles, the 10 miles per hour, and 11 a.m. And we're gonna have to do two parts. First, we need to figure out how much distance they can cover in a certain amount of time. And then we need to backtrack to see what time they would need to leave in order to arrive on time. So first, I'm gonna know, okay, 10 miles is what they're doing in 1 hour, which means that in 2 hours, they're gonna cover 20 miles. Which means I need to get to 25, right? So 25 miles is gonna be 2.5 hours, right? If I went 3 hours, that would be 30 miles because we're counting by tens. So I need to go right in between that 2 hours and 3 hours at 2.5 hours. All right, so now if I know that I need to be there at 11 a.m., I'm gonna say, okay, 11 a.m., and I need to subtract out the 2.5 hours. So what I would do is I would say, okay, 11 a.m. minus 1 hour would be 10 a.m. 11 a.m. minus 2 hours would be 9 a.m. And if I go a half an hour before that, I'm at 8:30 a.m. Our last word problem for today is a geometry problem. It says a water sprinkler sprays in a circular pattern a distance of 10 feet. What is the circumference of the spray? Now, we have a formula at the top there. We see circumference is 2 times pi times the radius. Now, we need to know a couple of things. First of all, circumference means the distance around a circle. So if you can imagine with me a circle and then put a little dot right in the middle of it. If you were to draw a line from that dot to the edge of the circle, that would be the radius. It's exactly half of the width of the circle. If you were to draw a full line all the way across the circle and through the middle to the other side, that would be the diameter. So the radius is half of the diameter. Now, if we're thinking about a sprinkler, you think of that sprinkler sitting right in the middle of the circle. And as it goes off, it shoots water from the middle of the circle out to the outer edge. And that distance, they say, is 10 feet. So since we know it's from the middle to the outer edge, that's going to be the distance of the radius. So with that information, if we can put those things together, then we have the right information to solve this problem, because we know that circumference is 2 times pi, and they tell us here pi is 3.14, times the radius. And the radius in this case is 10 feet. So the circumference, the distance around this circle, is 62.8 feet. Thank you so much for joining me today for this Math Roundtable recap. I enjoyed solving these problems with you and hope that you learned something new in preparing for your future exams. You can check us out at helmsacademy.org or by subscribing to our YouTube channel or checking us out on Instagram and Facebook.